Hello everyone. Welcome back to the day 18 of our Teamcenter interview preparation series. This is part 2 of our SOA basics. A small recap from part 1. SOA is Teamcenter service menu. Your application calls named versioned services instead of touching the database directly. And we walk through the four-tier architecture: client, web app, Teamcenter server, and database. If you haven't watched part 1 yet, I would recommend starting there. I will link it in the description. Today, in part 2, we go deeper into how SOA actually works under the hood, the building blocks of a service call, the three ways you can connect to Teamcenter, and the complete journey a request takes from your application to the server and back. Let's get into it. Now let's look at the building blocks of SOA. There are three things you need to understand: service library, operation, and service data. Let's use our restaurant analogy again to make this clear. Service library. Think of this as a section of the menu. A restaurant menu is divided into sections: starters, main course, desserts. In SOA, services are grouped into service libraries. Each library covers a related area of Teamcenter functionality. For example, the core library handles general Teamcenter operations. The CAD library handles CAD related operations. The manufacturing library handles manufacturing operations. Each library has a name and a version. On the slide you will see Code 2013-05, CAD 2012-09, Manufacturing 2011-02. The version tells you which edition of the library you are using. These specific version strings are examples. The actual versions available in your Teamcenter installation depend on which release of a Teamcenter your company has installed and which service packs have been applied. The important thing is the pattern, not the specific numbers. Operation. Think of this as one specific item on the menu. Within each library, there are individual operations. Each operation does one specific thing. For example, create items creates new parts in Teamcenter. Find objects searches for objects. Get properties reads the property values of an object. Every operation works like this. You prepare an input object, a structured package of information saying what you want to do. You send it to the server does the work, and it sends you back a result called service data. Service data. Think of this as the plate of food that comes back to your table. Service data is the standard result package that every single SOA operation returns. It is a wrapper that contains everything the operation produced. It has three things inside it. First, the objects that were returned. For example, if you searched for parts, the matching parts are in here. Second, list of what changed, which objects were created, which were updated, which were deleted during this operation. Third, partial errors. This is a list of any problems that happened for individual objects. We will explain this properly in the error handling section. One important thing about how objects come back in service data. The objects are returned as model objects, which is Siemens term for a Teamcenter business object that has been loaded into memory on the client side. Each model object has a UID, a unique ID that permanently identifies that object in Teamcenter. Think of the UID like an Aadhaar number or a passport number. It never changes and always points to that one specific object. Now, how many of an object's properties you can read depends on something called property policy. Think of a property policy like a shopping list your application hands to Teamcenter before making a call. It says, when you send me back parts, please include the part name, part ID, and creation date, but I don't need everything else. Teamcenter then loads exactly those properties into the model objects in service data. If you need a property that wasn't in the policy, you have to make a separate get properties call to fetch it. This design keeps response fast. You only load what you actually need. Now, how do you actually connect to Teamcenter SOA from your application? There are three ways, and each one is called a client binding. Think of a client binding as the type of phone you use to call a restaurant. You could call from a regular phone, from a smartphone application, or from a website. The restaurant is the same, but the way you connect is different. Similarly, Teamcenter SOA is the same, but the way your application connects depends on what kind of application you are building. Client binding 1 C++ client. This is for desktop applications. If you are building an extension for the Teamcenter Rich client, the desktop application, you write it in C++. Siemens provides pre-generated code files called stub files that already know how to talk each SOA service. You just call the functions in those stub files from your own code, like using pre-built remote control. The key class you use is called Teamcenter SOA client connection, and this class handles your login session. The pattern is always login first, do your work, log out at the end. Client binding 2 Java client. This is for standalone Java applications and server side integrations. The Java SOA client is used when you are building a standalone Java program that needs to talk to Teamcenter. For example, a batch processing tool, or a backend integration job, or a Java based middleware system. Siemens provides .jar files, which are Java library packages that contain the stub code. The key class here is com.teamcenter.soa.client.connection. Same pattern. Login, do your work, log out. Communication happens over HTTP, the same protocol your browser uses. A clarification worth noting here is Active Workspace, Teamcenter's modern browser interface, does not use the classic Java SOA client internally. Active Workspace primarily communicates via REST based services under the hood. Client binding 3 REST or thin client. This is for modern web and external integrations. REST is the most universal option and is the direction modern Teamcenter integrations are moving. REST means sending standard HTTP web request, the same kind your browser makes every time you open a website. If you want to connect Teamcenter to a mobile app, a custom website, a Python script, or an external system, REST is usually the right choice. A few things to understand about how REST works with Teamcenter. It goes through a REST gateway or the Teamcenter REST services layer. This is a configured component that exposes Teamcenter services over HTTP. Not every internal SOA operation is automatically available as a REST endpoint, only the ones that have been exposed through this gateway. So, REST gives you broad access, but it is not a direct one to one mirror of every SOAP based service. For authentication, you send your credentials to a login endpoint, and Teamcenter sends back a session cookie. You attach that cookie to all your subsequent requests in that session. The response comes back as JSON, a structured text format that every modern programming language can read easily, like a labeled list of values. Let's now walk through what actually happens step by step when your application makes a SOA call to Teamcenter. We will trace one call from start to finish. Imagine your application wants to create a new part in Teamcenter. Here are the 6 steps. Step 1. Your application makes the call. You write the code that says call the create items operation, and here is the input, the part ID, the part name, the part type. The SOA framework takes your input object and converts it into a format suitable for sending over the network. This conversion is called serialization. It's like putting your letter into an envelope. Step 2. The request travels over the network. The packaged request is sent from your machine over the network using HTTP or TCP and arrives at the web application tier. Think of this as your letter being picked up by the postman. Step number 3. The server receives and routes the request. The Teamcenter web server receives your request. It checks who are you? Are you logged in? Which service and operation are you calling? Then it passes the request to the right handler inside the Teamcenter server. This is like the postman delivering your letter to the right office. Step 4. The actual work runs on the server. Now the Teamcenter server does the actual work. It takes your input, runs all the business logic, checks permissions, validates the part ID, applies any company specific rules, and creates the part in the database. This is all happening on the server, not on your machine. Step number 5. The server packages the result. Once the work is done, the server collects everything into a service data object. The newly created part goes in. If anything went wrong for any individual object, that error information goes into the partial errors section. The service data is then serialized, packed into an envelope, ready to send back. Step 6. The response arrives at your application. The service data travels back over the network to your application. Your code unpacks it, looks at the objects returned, and checks if there were any partial errors. If everything went fine, you now have the UID of the newly created part and you can do more work with it. That is the complete round trip. Every SOA call, no matter how simple or complex, follows these same 6 steps. That's all for day 18. To recap, we covered the 3 building blocks of SOA: service library, operation, and service data. We covered the 3 ways to connect: C++ for desktop, Java for standalone programs, and REST for modern web and mobile. And we trace the complete 6 step journey of a SOA call from your application all the way to the server and back. In day 19, we see how does SOA actually handle errors, and we will do a full and clear comparison of ITK versus SOA. Thanks for watching. See you in day 19.